Okay, so as part of your algebra lesson for this week, you are completing this Desmos activity. I wanted to quickly go through a few of the more challenging parts of the activity in this video to help you as you complete this. So in this first Notice and Wonder, you can see a graph on the left, and this graph is representing US CD sales for this particular album. A few things I want to point out to be careful of. The first is noticing units. So the y-axis is US CD sales in millions. So you can see it looks like 300, but really it's 300 million. So the initial value or the starting place for the album sales would be a little over 300 million albums. We also have an equation here. There's a slope of negative 29 and then the initial value or the y-intercept of 368. So the three things that I noticed were that there's a negative slope, meaning that the sales of this album decreased over time since 2008 when the album was first released. I used the slope here, so I said the album sales have decreased at a rate of 29 million CDs per year. And I also noticed the y-intercept is 368. So in 2008, when the album was first released, the initial value of the number of CDs sold was 368 million CDs. Okay, so I skipped ahead to slide 10 for the video. So this part of the activity is really about getting across this idea of line of best fit. So looking at all of these different options, what I want you to think about is which of these lines best fits the data points. In other words, which one of these lines is closest to all of the green scatter points. So there's some that kind of make sense right away that they don't match at all. Like in C, you can see clearly the data points have this general positive slope, but then the line itself, like the black line, is flat. So clearly C doesn't really work. So because I'm going from best to worst, I'm gonna put C near the bottom because it's a pretty bad line. And then another bad one would be B. It's clear that B is the opposite of the scatter points. So the scatter points have this like positive slope, and then the black line has this negative slope. So B is also bad. I might even say that it's worse than C because it's actually going in the opposite direction, whereas C is just flat. So that's debatable, but let's say B is actually the worst. E is a little better, but it's still not touching any of the scatter points. It's still not touching any of the green points. It's separate, so I'm going to leave it towards the bottom of the list. And then I'm left with A and D, which are both look much better. You can see for both of them, they're pretty close to touching all of the green scatter points. It looks like D might be a little bit better because you see how D is actually touching all of the points, and then for A there's a few points that are farther away from the line, so they don't quite fit or don't quite match the black line. So I'm going to say D is the best and A is the second best. Okay. So this is the same points that you were just looking at, and now you have a chance to actually make your own line of best fit. So I'm going to play around with this a little bit and see if I can get the line to match the scatter points as best as I can. So one thing you'll notice as you play with this is you'll probably run into a situation where you're like, should the points be below the line? Should the points be above the line? And I actually want you to think of placing the line so that about half of the scatter points fall above the line and about half of the points fall below the line. And we'll talk more as the unit goes on about why that is. but we want the line of best fit to fall in a place where about half of the points are above and half of the points are below. So it's not going to be perfect when we're doing it by hand, but I'm going to end up with something that looks like this. So now thinking about why my line of best fit makes sense, I want to actually think about the units of my graph. So on the x-axis, I have number of oranges. On the y-axis, I have weight. Okay, so in the next part, we're asked to explain why it makes sense. Okay, so looking at the units, I can start to parcel out what the different points mean. So let's start with this point here. So I want to pay attention to the label on the x-axis, which is number of oranges. So this is telling me if I have 5 oranges, the x value of 5, 5 oranges in the box, it's going to weigh, going over to my y-axis, it's going to weigh about 1.502 pounds on when I weigh it on a scale. So in general, we can see that the trend is that the more oranges we have, so as we have 3 oranges, 4 oranges, 5 oranges, 6 oranges, 7 oranges, so as x increases, or as the number of oranges increases, y also increases. So as the number of oranges increases, the weight of the box increases as well. And that makes sense, right? The more oranges that you put in the box, for each additional orange you add to the box, the weight is going to increase, which gives this positive slope that each point is a little bit to the right of and above the previous point. As oranges increase, the weight of the box will also increase. Okay, so the more oranges there are, the heavier the box will be.